Hey guys, how you doing on this rainy day? I heard there's a particular kind of front that's moving in because of this rain. I wonder what kind of front could be coming in the area that's causing all this rain. Wait, we're not on that unit anymore, are we? No, 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 no. All right, let's jump out into space. We're going to be going through only 4 slides, but we're actually covering a lot of material. So what we're going to do is kind of revert back to number 21 in our notes and probably be able to fill out everything up to number 25. Okay? So let's get this thing moving. Okay, we learned yesterday that a nebula is a collection of gas and dust in space. And what this does is it kind of just sits out there like fog. It's just matter that's floating out there. Okay? And that would be called a nebula. In some of the space exploration shows on TV or movies, they'll often talk about a nebula. And it looks very similar to the picture we have here for the protostar, except that the protostar, okay, now we're getting over toward 22, number 22, okay, that's a nebula that shrinks and flattens out because of the amount of mass there. Okay? It gets so much mass that it actually starts forming its own gravity field, if you will, and it shrinks. And that's where we start to get matter moving up against each other. Yes, it's cold in space, but the more that it moves up against each other, you do create some friction. Okay? So we've dealt with 21, and that spinning nebula that spins and flattens, and it shrinks also, is called a protostar. Okay, it shrinks and flattens. Okay, I'm going to move on to that next one real quick. All right. Main sequence stars are the ones that have the longest life. Because of the type of atoms and gases that are in it, it tends to burn for a really, really, really long time. These are the ones, the main sequence stars are the ones that form in a healthy way, if you can put it that way, and that actually go through a very long lifespan of the rich and famous. Yes, but they have the longest one because they're kind of structured in such a way that for longevity. Okay, it just happens that way. Okay, so most stars in the universe are like this, from what we can tell, and that includes ours. Ours appears to be a main sequence star, and they have the longest lifespan. So we actually addressed number 23. Most stars in the universe, including ours, appear to be classified as a main sequence star. Okay? And that would be a key point to remember if you go to take on astronomy later on, that our star classifies as a main sequence star. And probably next week, we're going to start looking at a chart that helps us identify, if we find a star out there, how do we classify it? We'll deal with that later. Okay? Now, these things start to burn, okay? And remember what I was saying about hydrogen versus helium. The hydrogen gets squeezed together, it gets fused together in fusion, and we start creating hydrogen. Okay? Well, hold on. First we're making hydrogen. When they get fused together, I misspoke, they actually form helium. Okay? Hydrogen has 1 proton. If I take 2 of them, fuse them together, I create helium. Okay? And that affects how it burns. Okay? And we're starting to create now a red giant. Almost all the hydrogen is gone. Why? Because it used all the hydrogen, fused it together, and made a different element called helium. Okay? And helium burns more red. Hydrogen tends to burn a little bit more yellow. Okay? So the star in which the gravity has collapsed the core, and the hydrogen's mostly gone, and it allows the surface gases, mostly hydrogen, to expand, spread out. That's a red giant. It actually changes in color. Okay? So gravity has collapsed the core, and the gases are expanding. That's the red giant. Okay? And the next one, okay, again, we've got most of the hydrogen gone, and the helium starts to fuse together just like the hydrogen did. Now the helium begins to fuse together and make other stuff. Okay, if I take 3 heliums, each of which have 2 protons in them, 2, 4, 6, I've just made carbon. And this is where stars start to get a little bit dangerous, because they're making atoms that have a bigger mass. Remember atomic mass from last year? And so their gravity starts to become very focused. I'm taking a long time with this, but I want you to understand the dynamics of what's happening here. Okay, so number 25, the stars are red supergiants that have almost no hydrogen, and you might want to write this down, helium fuses and creates other atoms. All right, that's it for today, and we will talk tomorrow. Don't forget to reach out if you get confused or if you can't find anything. Thanks, y'all.